HPCC Systems presents HPCC for Managers. Lesson 5, the HPCC Clusters. Now this lesson introduces the HPCC clusters, which you define and use according to your needs. There are two types of clusters in the supercomputer layer. Number one is the data refinery, or commonly known as THOR. THOR named after the god of thunder, with his hammer used to hammer the data into submission. It's used to process every one of billions of records in order to create billions of improved records. THOR also works with an ECL agent used to process simple jobs that would be an inefficient use of the THOR cluster. We'll talk about the ECL agent in an upcoming lesson. The second type of cluster is called ROXIE, or the Rapid Data Delivery Engine. This cluster is used to search quickly for a particular single record or sets of records. Now let's look at the cluster architecture. The architecture of both THOR and ROXIE are exactly the same, using the commercial off-the-shelf components, or COATs. The components are homogeneous, which means that all the processing and disk storage components are exactly the same or very similar, and the system is very tightly coupled. The HPCC software also creates a unique data parallel processing environment for THOR and ROXIE, and performs functions as both a processing and distributed data storage environment capable of analyzing terabytes of information. If you were to visit the data center in Boca Raton, Alpharetta, or Dayton, they will take you, show you the THOR cluster, show you the ROXIE cluster. The hardware components look exactly the same, and they are the same. Now, how's data loaded on the THOR cluster and the ROXIE cluster? And the difference is very great. First of all, in THOR, this is where all the data processing happens, the data crunching, the data linking, the data fusion. The loading is controlled through a special server called the distributed file utility. It typically arrives on a landing zone, or you might hear the term drop zone, and again through a variety of transfers, either by direct copy or remote copy, or through file transfer protocol, FTP. The file movement is started by the DFU, the distributed file utility. Data is then copied from the landing zone and is distributed or sprayed as evenly as possible into the data refinery, or THOR. The data can now be further processed using extract, transform, and load processes of the ECL language. Data retrieval then places the file back on the landing zone, despraying if the vendor requests it, or it can be pushed forward to ROXIE and used in a query. So a single physical file is distributed into multiple physical files across each node of a cluster, and the aggregate of the physical files creates one logical file that is easily addressed by programmers of ECL code. We don't care if we've sprayed onto a 20-node THOR, or a 400-node THOR, or a 2,000-node THOR. They're all split into physical file parts. We don't care. We always reference our file as one logical file. Now, on the ROXIE side of things, slightly simpler and a little different. Data inquiries are deployed using the ECL watch or the ECL command line tool. And finally, data moves in parallel from the THOR nodes to the receiving ROXIE nodes. The parallel bandwidth utilization improves the speed of putting our new data into play. So let's talk about the differences in cluster performance. First of all, in THOR, our largest database file has 7 billion records, and I'm sure that's greater. This slide sometimes has outdated statistics, and it's so hard to keep up with it. But as of the last information that we had, our largest Boolean search file was 100 billion records. Our largest intermediate file generated in a production process was 5.2 terabytes. Most records generated by a production join operation, 278 billion in 20 minutes. A terabyte stored in 3 minutes and 6 seconds. More than 24,000 data sets with multiple files received and processed each year. 6 trillion records processed monthly. Several million new records added daily. Our largest work unit is a business header file build that has 546 graphs. And our longest process is a person header build that runs approximately 60 hours. Our ROXIE cluster has more than 12 million queries processed daily in production. The largest number of queries for a single query type is over 4 million. Total daily processing time for daily queries is approximately 3.2 million seconds. Average response time for daily queries is around a quarter of a second. Average peak simultaneous connections are 2,500, and our tested throughput of more than 50 million queries per hour on append of the accurate data link to a person record on a 100-node system. Finally, let's look at the data flow of the clusters and how they interrelate and how they react together. Again, starting at the top, we have raw input data, where we have many thousands of data files, structured and unstructured, on a daily, weekly, or monthly basis. Those are loaded into THOR, processed by THOR on many hundreds of nodes with petabytes of storage and terabytes of memory. And then when ready, we parallel copy the cleaned and linked and processed data to the ROXIE query using a 1 gig per second parallel copy pipeline. ROXIE receives the data, which only has a few hundred nodes, meaning it's also stored in a compressed format, basically for storage and speed. It only uses a few hundred nodes, hundreds of terabytes of storage, and 100 gigabytes of memory. The users from the outside world, finally, using web or SOAP or batch interfaces, can retrieve their data in sub-second response times. So, in summary, you should now know the different types of clusters, THOR and ROXIE, what their overall architecture looks like, and how their data is loaded onto the clusters, and finally, how the data flows through the system. This concludes this overview of the HPCC clusters. When you're ready, proceed to Lesson 6, and we'll give you a little overview of the ECL language. Thanks again for watching.